BST insertion feels complicated because of recursion, but the actual algorithm is just repeating one tiny decision again and again, left or right. And once you see the return phase visually, the whole thing finally clicks. Alright, binary search tree. One simple rule: smaller values go left, larger values go right. Right now our root is 50. 30 is on the left, 70 on the right, and below 30 we already have 20 and 40. Now let's insert 35. The public insert function just calls a recursive helper. So we start at node 50. First question: is this node null? No. So now we compare. 35 is smaller than 50, so we move left. That means the value belongs somewhere inside the left subtree. Now recursion takes us to 30. At node 30 now, 35 is greater than 30, so this time we go right, and we land on 40. Now watch carefully. 35 is smaller than 40, so we try going left, but 40 doesn't even have a left child. And there it is, null. That's the base case. This is exactly where the new node should be created. So recursion creates a brand new node containing 35 and returns it. Now comes the important part. That returned node bubbles back up the recursive calls and gets attached to 40's left pointer automatically. We never manually connected 35 ourselves. Recursion handled the insertion during the return phase, and just like that, 35 is now part of the BST. Now let's look at a completely empty tree. No root. Nothing. What happens if we insert 10? Insert rec gets called immediately with null. Same base case as before, but this time it happens at the very top. No comparisons. No moving left or right. Nothing. So recursion creates the new node, returns it, and that returned node becomes the root itself. That's the cool part. The exact same recursive logic handled a deep insertion and a completely empty tree. One base case covers everything. Alright, last case. What if we try inserting a duplicate? Let's insert 40 again. 40 starts at the root. 40 is smaller than 50, so we go left. Now at node 30. 40 is greater than 30, so this time we go right. And we land on node 40. Here's the key moment: 40 equals 40. Neither the less than condition nor the greater than condition fires. So neither branch runs. The recursion simply returns the current node, unchanged. No new node gets created. That means this BST ignores duplicates silently. And that's BST insertion. At every step, recursion just asks one question: left or right? Eventually it hits null, creates the node, and the return phase reconnects everything automatically. Time complexity is O of h, O of log n in a balanced tree, O of n in the worst case. And honestly, once the return phase clicks, BST insertion suddenly feels way simpler.